Good morning to week two. Welcome to week two of our 8-week format, data science and big data analytics. This week, um, you'll be exposed to and demonstrate your knowledge of big data in several different functional areas, um, including healthcare analytics, and the connected factory or advanced manufacturing, and also smart cities, how data is being used within cities to hopefully improve life. Oftentimes, it's being used to improve security in cities, but that material was it last week, so we'll talk about that. Okay, weekly objectives, or actually, I'm sorry, the overview of this week's. We'll talk about um, big data and data science in general, kind of uh, more foundational framework stuff. If you're deep into just application development, if you're a software engineer, you're probably not necessarily paying attention to big data terminology and whatnot and thinking about it. But some of you are in effect big data engineers, so this is not new material for you. Um, and then we'll go over that. There's 2 assignments, and you've got, of course, dissertation resources every week. I hope you're watching them, and I'm sure you're not. I've only seen a couple of views of this video, so I don't hold out a lot of hope that you're watching the supplemental material, but from Dr. Brown. But if you are watching Dr. Brown's videos, and you're curious about anything, shoot me an email. Or even if you're not curious about anything, if you have watched Dr. Brown's supplemental video, shoot me an email and let me know. Let me know what you thought about it. And yeah, love to hear your feedback. Okay. And um, from the syllabus, we have electronic health care. There's basically 2 terms rolling around, one much more cosmic than the other. Talk about big data use in healthcare and where we think that's going. But we'll also talk about this the concept of a connected advanced manufacturing facility and all the data that's being used there. And yeah, the IoT, we don't really get into that much, other than in the smart city paper, which you write, but the material for that was last week. So again, the 8-week courses are a 16-week semester smashed into 8 weeks. I would also love for one of you, any of you, all of you, to email me as to why you chose the 8-week. There's a 16-week semester for this course available. Why'd you choose the 8-week one? What's the advantage? Be curious to know. Okay, so back to foundations. Remembering the 3 V's. Volume, yeah, just the sheer amount of data, because of all of the sources and the fact that I don't know, 1.5 billion people have a computer in their pocket now, produces a large volume of data. But I think, just extrapolating from my work experience and my personal experience, that video is is adding the largest amount of that when it comes to, especially now. There's a this could be a potential research topic. There's a size on disk, a sheer, bit size, file size, um, ratio to how much information, no kidding, data is available in that file, in that piece of digital information. I think video is causing the largest explosion. I mean, you've got, good grief, all the videos on YouTube, all the videos on TikTok, videos posted on Instagram and Facebook, um, and they all, I mean, they're not small, when it comes to, like, compared to a text file or a CSV file, which has very definitive data. Imagine if you had a CSV with every American's name, address, social security number, and all their credit card numbers. It wouldn't be large, really, in the scheme of things. Wouldn't be large at all, but it would contain, uh, you know, a density of information per bit or whatever, per megabit. Um, that would it would be staggering. But you've got video volume, a lot of volume of video out there that's not yet being mined per se, though it will at some point. Every time you see a video, you may be watching whatever the person's doing on TikTok, but think about the data in there. What are they wearing? Where are they? What are they doing? Who are they with? What other objects are in the frame? You start thinking about all of that as data, and then combine that with the metadata of the video itself. I think that accounts for a lot of the volume, and I think it will grow as that video, the raw footage, becomes analyzed, and information about the raw footage gets stored alongside that. It'll grow the size of it. And then just look at all the generators of video data that have happened in, well, your lifetime, not necessarily mine. Cell phones, just enormous cell phones, traffic cams. You have hundreds of thousands of law enforcement officers wearing body cameras. Um, every toll booth, there, security cameras. Look at all of the security footage, and it's just being recorded. It's not really being analyzed. Again, there's a lot of data in those volumes of video data that we're not looking at. I mean, down to the mood that the person is in by facial recognition. Artificial intelligence is able to pick out just an enormous amount of information. So yeah, volume. Um, and then yeah, that leads to a variety of data, and um, you guys are already used to working with that sort of thing if you're in IT, period. I mean, like a web developer, what have you guys got to deal with? JSON and or XML. So you've got key value pair data, tagged data. You got structured data down in a MySQL or SQL Server database. You got images out on hard drive. Really, they may be in a database. I'd like to know if any of you folks working on applications are storing images that are used on your web or mobile application in a database, or if they are just being stored traditionally as files. That'd be interesting to know in the discussion. So yeah, variety. You've got text coming in myriad formats, social media posts. You've got categorical data and discrete data like likes or don't like or don't like, click, didn't click, how long you watched a video, the comments you made, sentiments. So you've got, text to be analyzed there. Web searches. What are people typing in to a web search engine? Which link did they click on? And again, video, audio, all of these different platforms. It's just staggering variety of data, and it's not like you can just throw a bunch of data into a data lake and magically make sense of it. It's all got to be treated somewhat differently, and and used, evaluated for its worth, evaluated for its accuracy, and there are, of course, other V's, and velocity. So yeah, volume, variety, velocity. This stuff is coming at you like a Walmart. They've got store data, social media data, supply chain data, um, HR, employee data, point of sale data, flying at the enterprise. I don't know, like a couple of petabytes an hour in all of data coming. Location of trucks, what products are on those trucks, the quantity level of a given product, at a given store, and as things approach, like holidays and whatnot, it becomes up to the minute, just in time, critical, with millions upon millions of dollars at stake, as to being able to handle that data in real time. If you're running low on a holiday supply at a store, and you're relying on a human being. I mean, we've all been to a large big box store. They're not going to, call 911. I need more Easter eggs or whatever. You need to be able to monitor that electronically, and it happens very quickly. What's Walmart got? 20,000 stores, and then smaller retailers like Dollar General, Dollar Tree. Yeah, just staggering speed at which that data is coming at you. And that's just in retail. There are other, think of, the internet, working in, the United States Cyber Force. Think of all of the log files and IP packets, and internet traffic, and that's happening globally, and they're trying to keep up with that data, that moving in real time at light speed. I mean, and we're talking milliseconds here, microseconds. Anyway, so that's how big data started. I think it was '08 was the first seminal paper on big data. So just a side note, when you're writing academically, if you're going to define big data, try and use an article that's like just about defining big data. And it's a seminal article. That seminal means the first. Foundational articles, and that kind of like everybody uses, everybody in that field that's actually working in it and actually writing and doing original research, uses seminal articles to define a certain thing, whether it's a framework or a definition of a term like big data. So yeah, so when you're citing, try and use a paper that makes a point about that, and it isn't just sticking a citation in there so it looks like an academic paper. All right. And so we did, volume, variety, and velocity. Those were the first three. It doesn't take long when someone develops a framework for folks to jump in and say, that's a good idea, and I had it. Gave me another thought. What about? And so we have veracity and value as well. With all of those, the speed, volume, and variety of data coming in, you have an increasing problem um, with the goodness of the data, veracity. Can you trust where it came from? Is it depending? If it's external to your enterprise, you absolutely have to worry if it's authentic or not. Particularly in cybersecurity, there's quite a bit of traffic that's not authentic. It's not really a person. Social media data. There's social media reviews that are bot uh, developed. Can't trust them for anything. Um, Even if you've got a trusted API, like a buddy of mine works for an environmental monitoring um, nonprofit called Neon, and they monitor atmospheric uh, conditions, about 20 different stations across the US, and it's used for everything from predicting the weather to long-term studies, um, forest fire prediction, all kinds of things like that. And you can trust that data because you know the origin, you know the institution that is publishing that data. You're grabbing it out of an API that has a relatively rigorous format. So in those conditions, you can count on the veracity. But there's other stuff, particularly if it's just human generated scraped stuff. You've got to put a lot of processing into the data to assure its veracity. And then value. When you're a large enterprise, you can't necessarily track everything. So the you have to put, even if it's just a relative assessment, and it goes into your enterprise architecture plan. You have to think about the value of your data. You can't store it all. So you have to have um, a, a dispensation plan. When are you going to get rid of it? How long are you going to keep it for? And other data is because of the importance of being able to make a decision in a timely manner, is absolutely important, and that's where you put the most of your effort as far as processing, displaying and acting on that data. Because if you don't, it's maybe survival of the organization. So there's uh, different ways to assign those values, different ways to assess. I helped a company assess the value of an email address that they had collected, as it pertained to subscriber retention. And so we looked at factors, basically a decision tree, um, to assign a dollar value. If we get an email, and if this happens, and if they stay around this long, and if then they generate X amount of income on average, statistically significant average of business. So yeah, there you go. So I've seen other frameworks that I think have taken it out to 9 different V's, but these are all academic thought pieces. None of this is like a technology tool. You know, you don't set the velocity settings, in a piece of software or whatever. These are all it's food for thought that rolls over into um, developing tools that can deal with these factors. And big data architects, if not big data analysts and developers, have to take this stuff into account as they're developing a data science plan, data management plan, those sort of things. And yeah, this infographic is getting old. I've been using it for several years, but I can this is from a website called Rack on Tour. It's a great infographic that shows. I think this was in 2016, and it shows projections, but some of it is current use, and it just shows the mostly the volume and variety. If you think about, there's I mean, back to talking about volume. There is a Nova, which is public broadcasting, PBS, public broadcasting service television show called Nova. And some years back, there was a segment on Nova that you can watch on YouTube called "Rise of the Drones," and it talked about video footage. And there was one particular that was in the prototype, one drone in particular that was in the prototype stage that used an array of inexpensive, high megapixel cell phone cameras. And I mean, we've all seen in the last 10 years, my goodness, right? The quality improvement in cell phone cameras. What is this, 2022? Go back to um, you know 2003 or 4 and look at some of the cell phone pictures that you took 20 years ago. They're hardly readable. They looked fine on that little tiny screen, but now some of the technology with these cell phones. Anyway, so they took these cell phone, so DARPA engineer, um, and created an array. I don't remember, 1,000 or so cameras that could look in one view, in one panorama. It could take high resolution video of an entire city in one pass. So it wasn't like, a cloud of these little drones, with cameras on them. It was one drone flying up there, 20,000 feet or so, and taking real-time video. And then what was really amazing to me was the digital image recognition software that was happening in real time. So this thing's creating, I don't remember, a terabyte a minute or something. Just a incredible volume of video data. But then um, when they processed it, they could all of the objects in the frame, and this is a city, remember, could be identified as a person, a bird, a tree, a dog, and then think about it. It's in real time, once the user of a system like this could identify that this person was, you know, an actual individual human, John Smith. That person could then be tracked. Their movements could be tracked, to include going into and out of a building, because once it recognizes, keep the same clothes on and all of that. Anyway, fascinating. Like I said, it's maybe 15 minutes. Rise of the Drones on Nova. So yeah, this infographic shows all those, personal area network PAN devices. Um, the first time the personal area network came to my mind, I was jogging and I had my phone playing music through Bluetooth earbuds, and I was tracking my steps on my fitness watch. So I had a personal area network going on of 3 devices talking to each other wirelessly, and all 3 of them. Uh, well, I guess the earbuds don't generate data; they display data to your ears. So yeah, uh, staggering. Anyway, just setting the scene. And this is uh, I don't know, informational, scary graphic. It's almost 10 years old now, but think about all the data that a government has to deal with. This one breaks the pie slices are in um, um, domains, not necessarily cabinet departments, but um, different problem areas, data domains that have to go into a data. And there's the yeah, um, and the let's see, what would that be? One, two, between 3 and 4 o'clock, you get 43 terabytes per day per drone, and yeah, 7,500 drones. Ha, yeah, that's exploding. Like I said, this is 2014. Anyway, yeah, big data, and it's only getting. I think it's growing. And this is not my original thought. A lot of people have written about this and spoken about it, but I think it's growing out of our control. We we can't use it all. We can't store it all. We can't make use of it all. We can't verify it all. We can't create legislation anywhere near fast enough to keep up with privacy concerns. Um, we can't secure it quickly enough. It's just spilling all over the place, um, which is job security for a PhD in IT. So anyway, yeah, it's just setting the scene when it comes to big data. If you don't work in this world or watch or think about it, it's interesting. I'm sure after a class like this, if by chance any of you weren't um, necessarily fascinated about big data, I think you will be in the future. So, yeah, one other thing I wanted to talk about here, for the software engineers, you're used to um, doing things cyclically, and I'm an old guy. I haven't developed software, no kidding, in production in a while. But I work in that world, so I pay attention to things like, agile processing, which to me, when I talk to software engineering friends and they talk about doing a agile, Scrum, uh, sprint, it sounds like what we used to call code and fix. But it is the way things happen so fast that you have to have a some sort of approach to it. But either way, regardless if it's old school, up to doing an agile sprint every month, you've got some sort of a process for gathering requirements, analyzing the impact on the system that those requirements will have, an estimation of what's got to change, which code elements, and the database and whatnot, what configuration items have to change. And then you've got to estimate and plan the work, how long that's going to take. And then you've got to factor in testing and verification that everything works. And you've got to have good test environments, good test data, good testers, people writing test cases. And then you've got to do fairly rapid deployment, CI/CD implementation, and around and around and around that circle goes. And iteratively, your applications gain functionality. Well, there's a similar uh, um, life cycle to data analytics, data analysis, and it it makes sense because everything starts with a problem. Even uh, you know, a software application starts with what's the problem? Well, it takes too long to do something, or there's an opportunity to make money if we can provide this functionality or whatever. There's always requirements, problems. Well, data analytics is similar, and it goes through um a process where you ask the question, how can we generate more customers, or you can't, and asking business questions of your data and of your analysts and your data scientists um, almost always requires uh, iterative clarification. Like how can we make more money? Well, let's see. How can we make more money? How do we make more money? You start seeing, well, we've got income streams from these five basic sources. Well, what are the specifics of it? How does stream one actually work? Well, when advertising this, and stream two is leasing property. And well, how do we make money with that? And what's our most productive property at all? When you start iteratively going through this, you will decompose functional decomposition. You'll decompose those analysis requirements into more and more um, specific objectives until you get down to the data, and that's when you go through the wheel and you identify the data that you need, you clean the data, you assemble it with other data, analyze it through a model, you choose what statistical or machine learning metric or model is going to provide the answer. You run the data through that, uh, report the results using storytelling and data visualization, and hopefully that results in some sort of business decision, and around and around and around and around you go. So it's very cyclical, a lot like software engineering in my observation. So there's key stakeholders, key players in that. Your actual business user, uh, from the lowest level clerk to the VP of a given area, are going to be business users that provide the no kidding detailed requirements and problems that your analysis will solve. Most analysis projects need some sort of a sponsor, some sort of executive has to want to know, or it won't happen. You know what I mean? It's just like anything else. If there's not executive leadership behind something, including a data science effort, it will likely fade. Then you've got a project manager, keeps everybody on track, keeps resources allocated, watches out for cost and schedule, requirements creep, those sort of things. BI analyst, business intelligence analyst, normally pulling data and representing it for decision makers. This is generally your person working in Microsoft Power BI or Tableau, that's able to take data, ideally from a data warehouse where it's been formatted and cleansed um, and stored where it can be pulled rapidly and accurately. And then that's displayed in a dashboard or a report of sorts. Uh, DBA is just your database administrator that does permissions and tuning and whatnot on the database. Data engineer is getting to be, in my observation, a newish pursuit. That's the person that sometimes they're called a data warehouse developer. My son does a lot of data engineering. He's called a SQL developer, but he's basically taking data from multiple point of sale systems employed by a business. They have through acquisitions, they've managed to have more than one type of system that uses different formats, completely different internal databases that have to be extracted, transformed, and then loaded into a data warehouse so that sense can be made of it for management. And it's pulling from Microsoft and sticking in Postgres, and so you got to know two different kinds of flavors of SQL, and you have to plan that stuff and do the moves, the migrations in a time sequence that makes sense. Sometimes the stuff's going on in real time. Sometimes it's like an overnight batch process where if you're in a simple enough scenario where all of your stores close at 5, you can do that kind of thing. So yeah, data engineering, moving data around and formatting it. You're not necessarily analyzing it. You don't really care what the data says or anything like that. You just are responsible for um, uh, pulling it out and putting it where it belongs, accurately, sustainably, inexpensively, automatically, generally. And then you got the top of the pinnacle. Your data scientist is the person that's using um, new approaches. Data science is it's a buzzword. It's not defined by like ANSI standard terminology, but it encompasses all of this. So to say that you're a data scientist, okay. Generally, though, if you don't know a little bit about statistics, or a good bit about statistics, a good bit about I would say more recent developments like machine learning, like classifiers and cluster analysis and data mining, those sort of things. Maybe moving into different kinds of data than just a good old RDBMS that has a rigid structure. Maybe if you're using a graph database to see connections between nodes that in some new way that wasn't used before, um, moving pushing the envelope when it comes to these algorithms and models. To me, that's more of a data scientist. But I've seen people with data scientist as their job title, and they're really just a business intelligence guy. So I think there's an article that came out. Oh, good grief, 2012 maybe. Data scientist is the sexiest job of the 21st century. So of course everybody wants to put put something cool next to their name, and you see that a lot with data scientist. But there's a lot of science involved, but virtually, virtually all science uses data. I mean, the natural sciences, certainly, astronomy, medical science. Everybody uses, all scientists use data. But I guess we had to have a term for someone who is not a scientist in one of those particular patterns, but looks at the data itself as its own domain to look at its characteristics and what we might do with it and how it operates and whatnot. So there you go. Just my thoughts now. Okay, and then yeah, here's your phases. Uh, Discoveries. When you're asking the organization what do we want to know, what's important. They have to prioritize. Can't do everything. Remember the value of data. But then prep, thinking of which model planning and building is what measure. Are we just correlating variables? Are we doing multiple regression? Are we looking at certain clustering algorithms, and then you got to build the model. You got to validate it. You might need to tweak it. There might be certain features of the data that are more impactful than others as far as your output's concerned. But this is iterative, and then you communicate the results. I said, data visualization, and then you operationalize it by um, uh, acting on it. What's the point if you go through, a 3-month gut wrenching project of talking to people and figuring out what they need, and then going through all the rigmarole to assemble the data and code up the analysis and make the results, analyze the results and validate everything and make sure that, yeah, this is important here. And then you put it in front of an executive or the board of directors or whatever, and nothing happens. What was what was the point in the first place? So that can be frustrating. Been there, done that. Okay, so that's just generic stuff on that. Healthcare analytics. There is, I don't work in this world. I am not that kind of doctor. But there is an enormous amount of work in this world, and it's important. Um, there's just terminology depending on what if you work in this world, this is all secondhand, and you know all this stuff anyway. But if you're just taking a look at it, there's a couple of different sources. This big data, but there's a couple of different acronyms that you need to keep together. EHR, and I only learned this a few years ago. Electronic health record is like a database of all of your health information. And there are different providers, so there can be some compatibility issues. It would be perhaps more effective if there was one single schema for everything that could ever be possibly stored about you health wise, you and everyone else, all other 331 million people living in the country. But there's several providers, but regardless, this is a database approach as opposed to the term electronic medical record, which sounds similar, but all that is really is scanning in paper records, and so now you've got them preserved, and they're more accessible. That was a good first step, but that's 25-year-old technology. But actually getting everybody into a very similar EHR would allow much greater, especially research across patients, which freaks everybody out, the privacy issue. But anyway, EHRs reduce errors because the data goes in and is validated by the application, which always helps, as opposed to just scribbling notes on paper. And because it is structured data in a database, it can be exchanged and analyzed and shared better. But think about all of the data. If you work in a hospital, if you work in this world, but if you don't, think about all of the data, especially across a populated country like the US or India or China, and across that patient, those patients, or Brazil, or name your populated country, millions upon millions upon millions upon millions of people. And one stay in the hospital starts to just rip data, because you've got patient monitoring systems in the hospital, but then now you've got my mother-in-law has a pacemaker that can dial up the doctor and download data. So you've got people are using Apple Fitbits for health monitoring. You've got glucose, blood level monitoring, and it seems like they come up with a new connected gizmo. You stick your phone up to the little patch you're wearing, and it uploads data to the the hospital, the cloud, the provider, whatever. But of course, healthcare analytics has uh, um, you know, enormous applications, broad applications, and an enormous amount of data supporting those applications. But as I was just saying, the sharing of healthcare data, just saying that gives people privacy concerns. And then there's ethical concerns with sharing that data as well, or how that data is used. And I think maybe the one you might have heard of that's most talked about, at least in the press, is being denied coverage because of a pre-existing condition, and then and insurance, and deciding who might be allowed to get coverage and who might not, who might be allowed to get treatment and who might not. But you're even seeing this uh, in hiring decisions. If and you're not obliged to disclose this stuff, but it could be that if you have a health condition, somebody doesn't want to hire you because you might have to be out for sure twice a month for testing or whatever, and they just don't want to deal with a known problem like that. So the release and open sharing and protection of health data is of course obviously a huge concern. Um, so yeah, like I said, you've got a discussion this week about um, the processing of big data in healthcare, so that matters. Now this one uh, dropped off of. We used to discuss this, but it dropped off. So this is just food for thought. Think about an advanced manufacturing facility. You've got uh, data from supply chain of ordering raw materials all the way through to production facilities. You've got uh, sensors detecting how much material is being used, the quantity of waste versus uh, actually effectively used material, quality. You can now look at the performance of objects that are coming off of an assembly line, and do a quality check and look at to see if maybe something is going out of alignment, or some material in the process is a substandard and causing issues. There's just myriad data sources and applications inside of a connected facility, and this can be something that makes furniture, could be manufacturing something highly critical like pharmaceutical medicine, or chemicals. Some of the the petrochemical industry, um, processing factories, plants, whatever you want to call it, um, have incredibly complex processes, and if the sensors aren't monitored and reacted to in real time, you can have fires and explosions, or waste, create a batch of a product that's substandard because the data involved was not monitored appropriately. So just an interesting infographic, but again, we're not talking or writing about the connected factory, but we do talk about this week um, uh, um, healthcare, big data analytics, and one of four of these categories. And I just want to look real quick and make sure that the instructions for that discussion did not change. Uh, discussions in week 2. Beg your pardon. Pick one. Yes, 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 yes. One of these four categories, and be specific. Don't just plop some information about healthcare analytics. Be specific to the challenges associated with data gathering. What challenges do information technology professionals face in data gathering, or storing and integrating that data, or analyzing that data, or more advanced knowledge discovery and information interpretation about that data? And there's only a couple articles in there. You're going to need to, those are just starters. Those are just in, just to get you going. You're going to need to hit the books for this one. And again, I'll please converse and don't lecture each other. I'm seeing, as always, replies that don't have anything to do with the person you're replying to, that don't extend the conversation. You're just trying to check a block. So we can try and avoid that. And then we have the research paper for which you prepared last week in week one, about it's a literature review. And remember, during the opening last week's lecture that two people watched, I described what a literature review is. So yeah, there's a lot of information about smart cities out there. The radical framework that is in the article is not the only one that's in the classroom this week. That's not the only one. Smart cities have um, traffic monitoring, uh, smart power grids, and gunshot monitoring systems that could triangulate where a gunshot happened. I mean, there's a lot of different sensors and systems that can go into a smart city, and there's a lot of case studies out there. Singapore, Stockholm, Sweden. There's Toronto, Canada. There's a lot of case studies out there. So a literature review. Again, if you don't know what a literature review is, look it up. Read a couple articles on what a literature review is. And it's and let's see what you got. Yeah, I'm curious to see how these turn out. Okay. In conclusion, big data is exploding. A lot of challenges still persist, and I think will grow personally. But in classmates, please don't lecture your classmates. And when they lecture you, don't tolerate it, please. When you see stuff that's obviously Googled, as I do, would you please do something about it? Don't sit idly by. As they say, the only thing needed for evil to prosper is for good people to do nothing. So there you go. Questions, concerns, please shoot me an email, and have a good day.